Today we are going to talk about just that, what makes Sonic special. I'm talking about speed. Speed is something that you're probably used to handle. In fact, if Sonic travels a long distance in a very short time, you could claim that he is going really fast. And if he moves a short space in a bigger time, you will say that he's moving slower. That's a good approach, so let's establish these ideas in a more rigorous way. When we want to know if something is moving fast or slow, we're actually thinking about how much distance in some time. And I think that crab meat is going really slow. But by now, let's consider only motion at a constant rate. Here, Sonic is moving forward, and let's say that he has advanced 400 meters in 4 seconds. The key question we should ask ourselves is, what distance is he going through each second? Well, because he is moving at a constant rate, he covers same distances in same times. So we must divide the total distance by the total time, in this case 400 meters by 4 seconds. We obtain 100, which means that Sonic is covering 100 meters every second. This is the value of what we call speed, measured in meters per second. So 100 meters per second is indicating the distance covers in 1 second. The bigger the magnitude, the faster he goes. Now we are ready to get into the definition. We have talked about displacements, and this is just a change of position, so we'll need to define the position of Sonic while he is running. Let's fix an origin and a checkpoint, and say that Sonic is at 300 meters when the stopwatch marks 10 seconds. Then we see him running and stop our watch after 4 seconds, so his final position is minus 100 meters. If we want to know the speed, we must calculate the variation of position, that is, the final position minus the initial position, and we have minus 400 meters. Then, to obtain the speed, we consider the magnitude of the displacement, which is the distance without sign between the initial and the final position, and divide by the time during the displacement occurs. We end with 100 meters per second, which means that Sonic is covering 100 meters every second. Note that speed is kind of a notion of the movement rate, and is independent on orientation. This makes possible the definition. The speed of an object moving at a constant rate is the magnitude of displacement per unit time, and it could be calculated by dividing the total distance by the time that it lasts. We can sketch a procedure to calculate constant speeds. First, establish the position of something in an initial time. Don't forget to fix origin and orientation. Then, check the end position at a final time. At last, use the definition divided the displacement by the period of time to obtain the speed. Now it's your turn. Use your knowledge about the speed to solve this problem.